problem for our group project we decided to do is number 27 of page 567. This is by Daniela Fabila and Isaias Ledesma. We got these 4 lines right here, and when we plot them, we're going to get this shape. So, once we got this shape, this is what we think the center of mass is right here. First thing we do is we find the moment of x. We're given this formula right here, and we got f of x squared minus g of x squared. So we take these f of x and g of x and we plug them in. So now we got that, we're gonna get we're gonna move out this 1/2 and we're gonna do this integral. This just cancels out. So now it's gonna be 1/2 rho to the integration of e to the 2x dx to the limits of 0 and 1. This is a u substitution problem. So we're gonna let u equals 2x, and we're also going to plug in these limits of integration to get these new limits of integration right here, which are going to be 0 and 2. Now, this du on the bottom, we can move this outside right here so it gets multiplied with this 1/2. So the result is going to be 1/4 rho e to the u to the limits of 0 and 2. And this is already integrated right here. So plugging our limits in, we're going to get e squared minus e0, so it's going to be e squared minus 1. Now multiply this by 4, it's going to get e squared over 4 minus 1 over 4. And this is actually supposed to be a parentheses right here for the rho. So the answer is going to be rho 7.13 for the moment of the x-axis. For the moment of the y-axis, we're going to use something, a similar formula, only now it's going to be x as our variable, and we are going to use not square these two terms. So now we plug it in as the last one, and this is going to cancel out, but the only thing is now we're going to get e to the x times x. So this is u substitution, no, not u sub. It is integration by parts, so we're going to use the tablature method. So right here, we simplify it down to this, integration, and you plug it in, and we're going to get rho times e minus 1. So calculate this, we're going to get rho 1.71 as the moment of the y-axis. Now we're going to find the center of mass. And the center of mass is given in a coordinate, x bar, y bar. Now for x bar, we're actually going to have to do a little bit more work to find it out, because we need to find out this new variable a for area, which has its own formula right here. Now for a, we plug in our e of x and our 0, and we get e to the x, integrate it, and you get another e to the x again, limits of 0 to 1, and e to the 1 minus e to the 0 is equal to e minus 1. So a is going to equal to e minus 1, which is also 1.71. So now we're going to look back at our formula for the center of mass for the x coordinate. We're going to plug it in right here. So it's going to be e minus 1 and to the integral of all this right here. Now we just do the math more, and like the previous ones, and we'll get x bar is equal to 1 over e minus 1, which is equal to 0.58197. Or you can keep it as is to get a cleaner number. Now for the y coordinate, it's very simple, but it's actually a lot faster now that we have a. So now we're going to plug in our a. We're going to do the same process that we did, only with a slightly different formula now. And we are going to get e to the 2x minus 0, and then we are going to do very similar math to what we did in the moment of x actually. And now we're going to get 1 over 4e minus 4 times e to the 2x to the limits of 0 and 1. Now we plug in the limits, and now we're going to get e squared minus 1 times this. Only now we're actually going to distribute out a 4, so we actually get an e minus 1. And what we're going to do right here is we're actually going to factor this out, so we get an e minus 1 and an e plus 1. So we get, in this next one, we're going to get 2 e minus 1's canceled out right here. So it's going to be e plus 1 over 4. So it's going to be y bar is going to equal to e plus 1 over 4, which is 0.92957. So now that we got our x bar and our y bar, we can plot both of these. As here, this is like a more cleaned up version, but this is like the actual numbers. So the center of mass is right here, and we got the moment of x-axis and the moment of the y-axis. And that's it. Thank you for watching.